you doing it? I guess so. We'll just find out. So I wanted to do a few examples from 6.1, and then we'll move on to the rest of chapter 6. So what if you have a right triangle and in general, we're going to use this naming convention from now on. Capital letters for angles, and the opposite side will be a lowercase of the same letter. And while we're doing right triangles, angle C will always be 90 degrees. It will always be a right angle. So what if we have the measure of angle A is 25 degrees, and little a is 14. And the goal is to solve the triangle. Which means we want to find all angles and all sides. Well, what should we do first?
Find the big B.
I think we should probably draw a picture. And then what were you saying, Tristan?
Find big B.
Find big B. Good, very good. So let's see. Does it matter how I label this? I've got angle C. Does it matter where I put A and B?
Not really.
Not at all. That's right. You'll get exactly the same answer regardless of how you label it. So let's see. Angle A, that means small a is opposite. Angle B, small b. Angle C, small c. And we have small a, angle A, and angle C. And yeah, Tristan, how do we find it?
Big B, we find it because we know that the internal angles of a triangle are going to add up to 180.
Good. So if we subtract A plus C from 180, we should get the measure of angle B. So let's see, 25 degrees plus 90 degrees. And 180 minus 115.
65 degrees.
Great. So we've got the measure of angle B, measure of angle A. How do we find B, little b and little c? How do we find those sides?
Trigonometrical.
Good, okay. So which trigonometric function involves, we need to use our side that we have. Which one involves side A? And which one do you want to, which side do you want to find first? Answer. Say again.
We're combining small b first.
Okay, which trig function shall we use?
Tangent.
Okay. And which angle?
25 degrees.
So I know that tangent is opposite over adjacent, and the opposite with respect to 25 is,
Not working.
and the adjacent B. And how can we solve this equation? Tangent 25 equals 14 over B for B. What do we need to do? The thing we're looking for is in a denominator. Yes, very good. So if we multiply both sides by side B, we don't have a fraction anymore, which is nice. And we get that B times the tangent of 25 is 14. What is the tangent of 25? So you can use whatever calculator you want. I use my phone. And if you use your phone, come on, you can put it sideways and get a scientific calculator. 466 3. What was the next digit?
0.
Okay, good. And now, what do we need to do to find B?
Divide over.
Excellent. And we get that B, we want to find B to 1 decimal place. We want to find trig functions to 4 decimal places, B, or sines and angles to 1 decimal place. So what is 14 divided by 0.4663?
I don't remember how many decimal places.
30.023, and we want to round to 1 decimal place. So we want to round to the place where the 0 is. If we look to the right of the 0, do we leave the 0 or bump up? Good. So this is 30.0. And now what do we need to do?
Find C.
Okay, how do you want to find C?
Use the same angle and the same small side.
So what trig function did you want to use?
You're going to use sine.
Good. So we know that sine 25 is opposite over hypotenuse, which in this case is A over C, and A is 14. So we got the sine of 25 degrees is 14 divided by C. And what can we do?
Multiply it.
Good. So we get that the sine of 25 times C is equal to 14. And to 4 decimal places, what is the sine of 25?
0.4226. And the other one's 1, so it's rounded.
So we're gonna leave it here?
Yeah.
Okay, great. And we get that C is approximately,
Was I wrong?
pardon? Did we get a different value? It could be in radians. If you're in radians, on mine, when I'm in radian mode, it says it a little RAD. When I'm in degrees, there's no symbol. Let's see.
Oh, you can actually switch on this one. I didn't even realize that. And we're supposed to be in degree.
Yes. So what did you get for C?
So, 33.12.
And we're gonna round to,
1.
good. Now, is there a way that we can verify, or at least feel better about the values that we got for the sides?
Verify using Pythagoras.
Very good. So we know that a squared plus b squared is c squared. So let's see, we were given A. We found B to be 30. And we found C. Oh, 14 squared, all of a sudden I forgot. All right. And 33.1 squared.
Yeah, 1,095.
1095?
Yeah, 1095.
Okay. And what is 196 plus 900? Do we feel good about these values? Why are they not exactly the same?
Because we rounded.
That's right. And almost always when we're doing, I'm sorry, Corey. Almost always when we're doing problems like this with real-ish material, we're going to get some error. Okay, great. Well, let's do another one like that. And I'm hoping somebody, in addition to Tristan, can help me. So let's solve the triangle. If little a is 12, little b is 11, and little c is 14. How do we do that? Is it even possible? So let's draw a triangle and label it and see what we've got. And actually, I just realized, with right triangles, we can't do that. But we can do that. Very good. Okay. Because today we're going to look at triangles that are not right triangles. But I wanted to do a little bit more right triangles first. So always when you start, throw up a triangle and label the information. And then fill in what we know. So what do we know? Say again. All right. What do y'all want to find first? Okay, very good. And how shall we do it? Excellent. So we said that A was 12 and B 11. And 144 plus 121 is? 265. And to one decimal place, what is the square root of 265? 15.3? 16.3, okay, very good. Great. We don't know any of the angles though. I mean, we know the right angle. That's all we know.
So you assume it's positive?
Yes, when we're looking at triangles, not part of a coordinate plane. So we're not solving an equation inside of a place where things can be positive or negative. We're just looking at a physical triangle that can only have positive edges. So very good, thank you. Do we know anything about capital A or capital B?
They need to add up to 90 degrees.
Yes. What is the sine of A?
12 over 11.
Careful.
16.3?
Yeah, it'll be
Oh, yeah.
12 over 16.3. Well, 12 over 16.3, that's a number we can find. To 4 decimal places, what is that number?
Uh, 0.7361. And it's going to be rounded up to 2 because the next digit's 9.
All right. Now, we've got that the sine of A equals 0.7362. So do we have any kind of information about how to undo sine? Like an inverse sine? Yeah, we can take the inverse sine of both sides. Over. And what is the inverse sine of the sine?
Victoria?
Vicky. Thanks, Trish. What is inverse sine of sine? What do? They do, indeed. So on the left, we get angle A. On the right, how do we do that? So on my calculator, if I tap second, the trig function row becomes inverse trig function row. 47.4?
Depends on how far we can go, if you go 4-1
One decimal place.
or 4.
Let's find angle B 2 ways to verify that we're doing it correctly. So how do you want to do it the first time?
We're finding B now, you said?
Pardon?
You said we're finding B now?
Yes.
Okay, we do the same thing for sine of B now.
All right, good. So we know the sine of B is opposite over hypotenuse. Well, opposite is going to be little b. Hypotenuse is going to be C, 16.3. So we have 11 over 16.3. And to 4 decimal places, what is that number? Okay, so we've got that the sine of B is 0.6748. And how can we get to B? Yes, we can take the inverse sine of both sides. On the left, what happens?
They cancel out.
Good. And on the right, we're going to evaluate an inverse sine of 0.6748 to 1 decimal place.
I got 42.4, but we're still wrong 0.2. Get that.
42.4,
Yeah.
all right.
It comes out to 89.8, so it's 0.2 off. We need to go further.
Oh, that's okay. So we found that angle A was 47.1 degrees, that angle B is 42.4 degrees. And how did you check, Corey?
Check if they were right. We got it together.
Good. So we know that the measure of angle A plus the measure of angle B should be 90. Good. And we have 47.1 plus 42.4. And you said you got 89 point.
Yeah, is the first one, did I give you 47.1 or 47.4?
I don't remember. Oh, 47.4. Yay.
Yeah, and then I got 42.4, but like I said, it was off 0.2.
Oh, that's okay. So at 89.8?
Yeah, that's it.
That's fine. That's very good. We're happy. Yes. Oh, no, cooling earth. That's good. Okay, you ask yourself, what in the heck do we do with the whole world that isn't full of right triangles? And we have a solution. For right now, I'm going to give you the law of cosines and the law of sines, but in a little bit we're going to prove them. So, the law of sines, you can write it two different ways. You can write A over sine A equals little b over sine angle B equals little c over sine angle C. Or you can flip it. Sine A over little a, sine B over little b, sine C over little c. And the reason that we might want to flip it is based on what we're looking for. It's nicer to have the thing you're looking for in the numerator, just easier. Before we write up the law of cosines, let's play with something where we can use the law of sines. So what if we have this is example 1 in the notes that I passed out. If we have the measure of angle A is 42 degrees, the measure of angle B is 75 degrees, and we're given that little c is 22 centimeters. Oh, we don't have enough. Let's fix this. So let's say that this is little a. How can we use the law of sines to find what's missing? And what can we find?
We can use sine over, or 22 over sine of 42 degrees is equal to,
So yes, a over sine A.
equal to b over sine b.
Great. So we've got 22 divided by the sine of 42 equals little b divided by the sine of 75. Excuse me. let's go ahead and simplify this before we put numbers in, or before we evaluate these signs. How can I isolate B? What can I do to get B alone? Good. So I'm just gonna write sine 75 in the numerator. And now it's easier, if you do that extra step, it's much easier to deal with the numbers in your calculator. But we do want to have one caveat. With trig functions, I want us to use 4 decimal places only, which means don't carry it in your calculator. Figure it out, write it down, and round it off. So to 4 decimal places, what is the sine of 75 degrees?
9659.
All right, and to 4 decimal places, what is the sine of 42 degrees?
6691.
Marvelous. And now we get that B is approximately 22 times 0.9609, all divided by 0.6691. And 1 decimal place.
31.8.
Excellent. Oh, we didn't even draw a triangle. Y'all should have yelled at me. So we just found little b is 31.8. We said that A was 42 degrees and B was 75 degrees. And that little a was 22. What should we do now? Excellent. Wait, now, it's not a right triangle anymore. So we don't have the Pythagorean theorem in our arsenal right now.
It's a cube, right? Or
Oh,
This is an acute triangle.
right. We pick a angle and then use the trig functions to see.
Okay, let's see.
Or you could just pick the angle for C since you already know the other 2 angles.
Right, what is the measure of angle C?
75,
So it'd be 180 minus, yes,
75 plus 42.
and 180 minus 117?
63 degrees.
All right. Now we can find angle C, side C, just using the law of sines again. So I've got little c over sine C, and I'm going to use, oh, which side should I use?
A, because it's not the estimation.
That's right, because A was given, we should definitely use side A. Also, angle A was given. So we've got 22 over the sine of 42 degrees is equal to little c over the sine of 63 degrees. And let's write those down to 4 decimal places.
The sine of 63 degrees is 0.8910.
All right.
691.
9-1?
Yes.
Okay, great. What can I do with that equation before I start putting numbers in?
Oh, it's multiply over sine 63.
Good. So I've multiplied both sides by sine 63. And that divided out. Now we've got that little c is 22 times 0.8910 divided by 0.6691, and to one decimal place, what do we get? And now we've solved the triangle. When the sides don't have units, we're just thinking of them as just a general unit. So now I want y'all to do this one with groups. And there are enough of you to have 2 groups. So please make groups. And solve this triangle. Sounds like a game show. We have little a is 45. Measure of angle B is 80. The measure of angle C is 25. And if y'all are quiet, I'm gonna be worried.